In this video, we're going to be learning the derivatives of sine, cosine, and e to the x. So the derivatives of sine, cosine, and e to the x all have cyclical properties, which means they will eventually repeat derivatives. Okay, so for sine and cosine, we can use this table. The two most important ones, the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine x. And if you want to keep going there, the derivative of sine of x, negative sine of x, we can factor out the negative 1, and we're going to have the derivative of sine of x. So we're going to have negative cosine x. We can do the same thing again. If we want to find the derivative of negative cosine x going after that, we can factor out the negative 1 and just find the derivative of cosine x. And the derivative of cosine x is negative sine x, and we're going to end up back at sine x. So all you need to know that the derivative of cosine x is negative sine x, and the derivative of sine of x is cosine x. Okay, let's start doing these examples. What is f prime of x if f of x is equal to sine of x? Okay, the f prime of x is just asking for the derivative of sine, which we know is cosine x. Okay, what is f double prime of x if f of x is equal to sine of x? So when we see double prime, that's asking for the second derivative, which is what we get if we apply the derivative twice. So it's going to be like d dx of d dx of sine of x in this case. Okay, we know the derivative of sine is just going to be cosine of x. And then we find derivative one more time. It's going to be negative sine of x. Okay, what is the third derivative? There's 3. We stop using the dashes at this point because imagine for the 400th derivative, we don't want to write 4,000 dashes. So after some dashes, we start writing numbers instead. Okay, so the third derivative of sine of x. Okay, we can just apply the derivative operator to just the previous one. So derivative of negative sine of x, that's going to be negative cosine of x. Okay, and then for the fourth derivative, we can just differentiate our previous answer again. That's going to be sine of x. And we see here, since there's 4 steps in the cycle, if we apply 4 derivatives, we're going to end up back to where we started. See, 1, 2, 3, 4. We're just going to end up back to where we started after 4 derivatives. Okay, so for f of 5, that's really just the first derivative of sine, because the other 4 don't matter. They just end up to where we started. So it's the first derivative of sine, that's going to be cosine of x. Okay, so for the 400th derivative, that's 4 times 100. So we're just going to have sine of x again. Because remember, if we were to do this 8 times, we would end back to where we started. 12 times, end up back to where we started, and so on. Okay, give one solution to the differential equation. F of x is equal to negative double prime of x. Okay, so for this one, when we have differential equations, for now, we have to think of terms of sine and cosine. Those are common answers to these. Okay, so let's try sine of x. Sine of x. Okay, and here, if f of x is sine of x, then negative double prime of x is the negative second derivative of sine. It's going to be negative. Okay, the second derivative of sine is going to be cosine and negative sine. Negative sine x. The two negatives cancel out, and we have sine of x equal to sine x, which is a true statement. Which means that sine of x is indeed a solution to f of x is equal to negative double prime f of x. Okay. So now moving on to e. So the derivative of e to the x is e to the x, satisfying the differential equation f of x is equal to f prime of x. its derivative will always be e no matter how many times you differentiate. So similar to this, if we were to make a table like this, it would just be e to the x, e to the x, e to the x, e to the x, over and over and over and over. Okay, now for the first problem. What is the 72,934th derivative of e to the x? Okay, so here we see no matter how many times you differentiate, so here, this derivative is just going to be e to the x. Okay, simplify. The summation from n equals 1 to 1000 of the nth derivative of x given that f of x is equal to ex. This might look scary, but let's just plug in a few values. Okay, starting at 1. Okay, and we're going from 1 to 3 all the way to 1000. Okay, you see here that since the derivative does not change e to the x, these are all actually useless. They do not change the value of e to the x. And we're going to be left with 1000 of these e to the x's. So our answer is going to be 1000 e to the x.